Hi everyone and welcome to Autodesk PowerMill. So we have already started the module number 2, which is all about the 2D toolpaths and machining strategies. And we have covered the face milling operation and 2D curve area clearance and 2D curve profile. So now we are going to cover today the chamfer milling operation and hole making operations. So let's get started. So I have already opened the Autodesk PowerMill software and let's create some geometries over here. So start with the block. I'm going to create a block here. Let's say that it's 200 millimeters in length, 200 in Y, and Z is 50 millimeters. Let's say that the Z direction is in the top. Okay, so we have the block with the size of 200 by 200 by 50 millimeters. Length is 200, width is 200, and the thickness is 50 millimeters. So for applying a chamfer, you need to create a geometry, okay? And for geometry, let's go and create geometry. So go to Patterns, go to Curve Editor, create a rectangle. So let's say I'm going to create a rectangle over here, and what I'm going to do is I'm going to offset this rectangle and say that the distance of let's say that 100 millimeters. So it creates an upper side. Let's say that minus 100. Minus 100. So where it may no. This make it okay. Split in between the sides. So just make a 30 minute inside. Just create this. Click this, go to offset and minus 15 newtons. Okay, so I just create an offset of this command, and I just don't need to create a copy. Just give and move at 15 millimeter distance inside. Okay, so click OK, and just want to create a pocket inside here, and we're going to create some hole operations also. So for hole operations, let's go to pattern and create another pattern, and go to curve editor and select holes. So just going to create holes with a radius of 5 millimeters. This means that the diameter is 10 millimeters. So just go make some random holes, okay, and some random holes over here, over here, and this direction over here. I say that this direction, okay. So just make some holes over here with a diameter of 5 millimeters. Okay. So I'm just going to give the name of first pattern which I just created and named it as a rectangle. And second is for holes, 10 diameter. Okay. Okay. So, we have a problem here. We just need to move this to other side. Okay. Go to curve editor and select this hole and move it. Select this hole. Let's want to move this. Okay. From this point to this point. Okay. Just give you a random value. Okay. For the purpose of knowledge. Okay. And go to rectangle. go to curve editor, and so say that trimmed fillet. So let's say that fillet over here, all the sides. Okay. So now it's back. Okay. So what we are going to do is we're going to create a pocket over here, and then we are going to apply a fillet. We're going to apply chamfer milling over here, and then after doing the chamfer, we're going to perform the hole making operation, and we're going to create a holes on this, or we can simply say that we're going to perform the drilling operation. Okay, and we'll discuss all these drilling operation in upcoming videos. Okay, so this is just a simple operation. So just go to toolpath and select the toolpath, and 2D curve machining, just select the 2D curve area clearance, and this one is the 2D curve area clearance, and set the definitions as a rectangle. Select the tool. Okay, it's already highlighted the inside area. Okay, go to tools, select the tool as a diameter of 10 millimeter, and say that this is flat and mill 10 millimeter. Okay, and select the lower distance. We want to move the material 20 millimeter, and we're going to move the material in terms of vortex right now, and the step over should be 5 millimeter. Okay, that's okay, good. We select the 10 millimeter anvil and choose the step over of 5 millimeter. Go to cut distance, set the cut distance as what we have set the lower limit is 20 millimeter. Set the lower limit step down 20 millimeter, and the stock is 20 millimeter. So we are going to remove a huge amount of material. Okay, so don't worry, just for the sake of practice. In real terms, this is gonna be done in a certain way. We can say that we're going to remove the material in multiple depth of cuts. Okay, all the things. Just calculate it, and this gonna make some vortex. So just go and set the vortex radius or minimum spacing point and all this stuff. Target radius and the C distance. Okay, so now let's go and simulate it. And go to halt, view mill operation, and see how it just looks like. So it's going to take a deep cut right now. So taking a 5 millimeter step over, and is going to remove all that material within a certain curve area. So that's why we call it curve area, 2D curve area clearance. Okay, so just create a 2D curve area clearance and create a pocket over here. So now it's time to create a chamfer around this pocket. So for chamfer operation, you need to go to home, select the toolpath, and select the 2D chamfer mill. Okay, and say that it's chamfer mill, and you need to set a tool. For the tool, you need to set as a drill and say that it's a chamfer tool. and set the taper angle of 45 degree. So this is a 45 degree tool. We are going to create a taper at an angle of 45 degree, and go to chamfer milling operation. Select the rectangle as your chamfer and the position lower end corner. Okay, so this shows that the bottom in the corner, this is the inside corner, top inside corner, and is the corner. Okay, you can select it as you want. Okay, so let's say that I'm going to select as a lower end corner. Let's say that the width of the chamfer is 1 millimeter and depth of the chamfer is 1 millimeter, and just click calculate. So it would have gone to create a 1 millimeter chamfer at the bottom of the side because we have selected the bottom. So let's go to simulation and check how it looks like. So chamfer mill and plate. So you will gonna see how the chamfer it looks like. So I don't think so that it makes it. Let me refresh it and say that the amount of chamfer let's say that the amount of chamfer is 2 millimeter. We will calculate it and plate. Still no response. So we have selected the corner side. Just click on calculate. Let's see. Chamfer and plate. Oh yes. So we have to select the location of the tool. So the cutting tool path, or we have the curve, is on the edge side. So we have selected the edge side of the curve. So this curve will be guided through and take a 2 millimeter chamfer at an angle of 45 degree on this side. So this is how we can create a chamfer at an angle of 45 degrees. So we created a chamfer at a 2 millimeter width and 2 millimeter in depth, and we have selected the chamfer position at the corner because our profile is located at the corner side. So therefore we selected the corner position for the chamfer. If your profile is inside of this object, so you need to select the top inside. And if your profile is at the bottom of the object, so you have to select the bottom side curve. And if you have the curve at the edge of the object, then you have to select the edge curve. So in my case, I have the curve on the edge side. So therefore, I have selected the edge curve and define your chamfer definitions that the width is 2 millimeters and depth whatever you want. So I have selected as a 2 millimeter width and 2 millimeter depth. No other changes you need to change. Okay, just calculate and you will get your desired result. So this is how we can create 2D chamfers. Or if you want to create chamfer on this side, you're gonna simply select and create your chamfers. So now let's move towards another operation which is known as the hole operation. So it's a very simple operation. So we're going to create some drills on this settings. So just go to home position and select the tool path. For this purpose, just need to go to simulation and exit the view mill. Yes, alt. And now we're going to see our holes positions. So let's go to home position, go to tool paths. For hole operation, you need to create a hole feature first of all. So this is here you have a hole feature set, or you will get access over this tab. Okay, so hole feature set hole feature, or you can create hole feature holes. So what I'm going to do is, we have already created a geometries hole, so just create holes. So named as a 10 millimeter, 10 mm holes, and create from curves or circles. Okay. So which circle you have? You need to select all these circles. Hold down the shift key to select the circles. Okay. So the absolute point is 0. Yes, it's absolute point. It's on the top of the face. And how much should be the depth? So let's define as minus 20 millimeter. Okay. Click apply and you see that it creates a hole feature or creates holes for your drilling operation. Click apply and OK. So now it's time to create toolpath for these hole features. Go to toolpath, click toolpath and go to drilling feature. So on the drilling feature you need to create hole for these geometries. So we have a lot of features here. We have a chip break, we have a contour bore, deep drill, drilling, fine boring, helical, and profile, rimming, rigid tapping, single pack and thread mill. We are going to discuss all these one by one in upcoming videos. For giving you a concept how the drilling operation is working, just click on the chip breaking cycle and I'm going to show you how it works. Okay, click OK and say that is drilling operations. So select your tool. So we have a drill tool at 10 millimeter. Say that the taper angle is 60 millimeter and the die is 10 millimeter. Okay. Go to drilling operations. Set the cycle type is chip break cycle. Define the top is hole top and the operation is according to depth. Clearance angle is 5 millimeter. Start angle is 0. And the peck depth is, you have to set the peck, how much it will take steps to cut down the 20 millimeter in depth of size. So I say that it will take 1 millimeter depth each time and cut down the material. Okay. So what will be the retraction if it takes 1 millimeter down and then go up fully retracted? So in the fully retracted, the cutter will be goes up to the safe plane and then again go down and take a 1 millimeter step. So that takes a lot of time. So for retraction, we said partial retraction and it will move up on the top side at an height of 5 millimeter. You can set it as 1 millimeter up. So this means that every time the cutter will go up at an 1 millimeter and then down, take a depth of 1 millimeter. That's okay. So we have selected the tool, we have selected the drilling operation. Just click calculate and so enable to drill the active feature. Duplicate feature is duplicate features exit in the feature set. Okay, say that the duplicate features is selected. You need to select the so just go to drilling operation and select the features. So here we have the feature which is at 10 millimeter there. Select here. Okay, select close. Now let's calculate it. So it's always saying that you have a duplicate feature. Just click OK. Go to whole feature. Select this feature you have created. Right click and click on the selected duplicates. Okay. So it selected the duplicates and just right click again and go to edit and delete selected holes. Okay. So it just delete all the duplicates which we have created and we have left the single ones. Now go to again to the tool path. We have drilling operation. Go to setting, select, OK, close, calculate it. So as you see that it just calculated the tool path. And go to simulation, click on drilling operation, and it will do the drilling for your holes. So this is how the drilling operation works. It's very simple. It's just like 1, 2, 3. You don't need to change any settings for that. We'll discuss all these operations in the upcoming videos, and we'll discuss thoroughly. So let's go and start view mill operation, and let's do it again. So let's say that I'm going to perform the drilling operation first. Just click on this. Let's make it a little speed high. Oh yeah, this is how the drilling operation is done at a depth of 20 millimeter. Now it's time to create a 2D curve area clearance inside this geometry. So that's it. It creates a pocket inside, and now it's time to create chamfer. Click on chamfer and click OK. And here it makes a chamfer on that. So this is how we can create the chamfer operation, and we create the drilling operation. It's very simple. It's easy. No need a technical expertise for that. It's just a simple 1, 2, 3 steps. Hopefully you enjoy these operations, and stay tuned for more updates and more learning. So this is how we can create, and that's it for the 2D operations. Thank you very much.